Today we use the investigative process in class to do a few experiments in reference to the Mobius strip. I wanted to walk through these math notes with you to highlight some of the important words that are going to come back to us in this course. So reading along, the investigative process is a way to study and learn new mathematical ideas. Mathematicians have used this process for many years to make sense of new concepts and to broaden their understanding of older ideas. So today we started out with a couple questions. Then we headed through exploration and conjecture. Now what we didn't explore quite a bit, but I have an example from some of your classmates, is the prove portion, the part that says whenever I do this experiment or ask this question, this result will happen forever. So in general, the process begins with a question that helps you frame what you are looking for. So for example, the questions today such as, what if the Mobius strip has two half twists? Or what will happen when that strip is cut in half down the middle, or when we cut down the line we created with X? Those kind of questions can help start an investigative process to find out what happens when you do all these little changes with the Mobius strip, or when you slightly alter it. So once you ask that question, then we make educated guesses, or we make our predictions. So our middle column, what we filled in, we predict. Okay, those predictions are called conjectures. The word conjecture is going to come back in this course over and over and over again. You are going to be asked to make conjectures continually, meaning given this picture, given this question, given this problem, given this equation, make a conjecture based upon the information that you are given. Okay? We call a conjecture a mathematical statement that has not been proven. So proven means you have given enough evidence or shown that something that you have said will happen infinitively, okay? Forever. So conjectures must always be proven. Now, a conjecture does not have to be right or wrong. Conjecture is simply a statement that comes out of your mouth. But you can, and you do, have the ability to prove a conjecture right or wrong. And we'll get into more of that later. But conjecture, very important word, will come back to us many, many times over. So then next, the exploration began. So we actually did the process of cutting the strips to find out what happens. So this part of the process lasts for a while because you gather information about the mathematical concept. Now I know we were cutting strips of paper today that have been taped together, but that is a mathematical concept. A Mobius strip is a geometric figure, and we were experimenting on that figure, so you were dealing with a mathematical concept. So another exploration and other that we may do later on is, and I'm reading, for example, you may have an idea about the diagonals of a rectangle. So at the left, I've drawn a rectangle as we know it so far. Four-sided figure, pretend those are right angles. Now we may not necessarily know what the diagonals of a rectangle are. They will be discussed later in this course, but for the purpose of talking about exploration, I'm going to draw them in for you. So these segments right here are what are considered the diagonals of a rectangle. Now I might have a specific idea about these rectangles, or I might make a conjecture. They cross each other. That is a conjecture. The correct word actually in geometry is they intersect each other. That is a conjecture. But maybe I'm going to make a conjecture about how long they are, or that they cut the angles that they intersect in half. So I would draw this rectangle on graph paper, and I might find out that my conjecture or my guess about the diagonal was incorrect, that they don't in fact cut the angles in half, or maybe they're not the same length. So when this happens, when we're experimenting, then you continue to experiment more until you have a new conjecture to test. So maybe I don't find out that they cut them in half, but maybe I find out that they cut them in a specific way. So that's my new conjecture. So instead of the angles get cut in half, I would say maybe the angles get cut in a 60-40 fashion. So this is the process in which we form a question or are handed a question, explore and conject or make a guess on what happens, and then once we get that question maybe shown to be correct, can we show that every single time? And this is where conjecture leads to proof. So one of the groups today in class made this observation, and I asked them to write it on the board. The observation that they made was that to them it seemed that the number of times you twisted the Mobius strip after you cut it, you got that many number of loops out of it. So if you twisted twice, you were going to get 2 loops, 2 connected bracelets together. If you twisted it 3 times, you would get 3 connected loops twisted together. So here again lies a conjecture, or rather I should say a new conjecture that this group could then test. If I twisted that strip 6 times, do I get 6 loops? So now, our next statement says when a conjecture seems to be true, so I've done my experiment 1, 5, 10 times. The final step then is to prove. Prove that that conjecture is always true. A proof is a convincing, logical argument that uses definitions and other proven conjectures in an organized sequence. So now proof is the big scary part about geometry. But what you just did today in class are the beginning steps of proof. The hard part about proof is using other people's conjectures, other things in math that have already done the experiment twice over and have said this is going to happen all the time. So proof is what we didn't tackle today. We tackled the first half of the process, and we will be tackling the first half of the process for quite some time. But remember, when we get to proof, it's a convincing, logical argument. And in that logic, that means that I have a definition, I have a statement, I have a conjecture that I proved the day before, and I can use it to make a proof about what I'm testing. So here was today's lesson in a nutshell. Hey, remember, the words that are highlighted here are important. They will come back to us. Now also, highlight these things for yourself in your homework so that when you're working through it, come back to these math notes and look for these definitions to help you answer your questions. See you in class.